Hey everybody, hope you're doing great. We're going to do 3 problems from the 518 to 522 worksheet, hopefully to get you guys going. We're going to do 1, 3, and 17. And for problem 1, notice I am going to write down the 2 equations next to each other. You guys have space to do this underneath the graph on your worksheet, or separate paper's fine too. So I'm writing the 2 equations next to each other so that I can work underneath them. And I'm going to rearrange these both into slope-intercept, or y equals mx plus b form, and then graph. Okay, so remembering for y equals mx plus b, I want the y in front, so I'm going to subtract x from both sides. Okay, and then hopefully we're getting a little better at this. The first thing I want to mention is these 2 things cannot be combined. And the second thing is that the x term goes in the front. Okay, we're almost there. We don't have y, we have 2y. So we need to divide everything by 2. And I have y equals, okay. Now remember, when you have this, my trick was to tell you to put a 1 in front, because it technically is 1x, and make this negative 1/2 x plus 4. Okay, now we're going to follow exactly the same process for this one. We're going to minus x from both sides first. Don't forget that this is not just y, it's negative y equals. These do not combine, and the x goes in front. And then we don't want negative y, we want positive y, so we divide everything by negative 1. Y equals, okay, now on this one, the 2 negatives cancel, and we don't need to write the 1, so we're going to write x. And on this one, the 2 negatives cancel, and I have positive 1. Negative 1 divided by negative 1 is positive 1. Okay, so let's graph them over here. Okay. So first we're going to start with the y-intercept of 4. So go up 4, 1, 2, 3, 4. Okay, and on this one, the slope is negative 1 over 2. That means down 1, right 2. So remember, the sign in the front, the negative or positive, affects the numerator either going up or down. And then the denominator, I'd always like to go right if I can, if I don't go off the graph paper. Okay, so down 1 over 2. Okay, and then remember to backtrack a couple of dots, making sure to fill the whole graph. And my first line is graphed. Okay, now my second line, I'm going to start at the y-intercept of 1, so here. Okay, now this is a little bit tricky. Notice there's nothing there for the slope, so that means it's 1, because this is 1x. And when we have a whole number, we put 1 underneath it for because that doesn't change the value, and it gives us a fraction to count our boxes. So positive 1 means we go up 1, right 1. All right. Okay, so I have the point of intersection right there, which is the coordinate 1, 2, 1, 2, 3. So my final answer is 2, 3, the coordinate where the 2 lines cross. Okay, moving to number 3. The directions are different. It says solve each system by using equal values method. Okay, and we worked on this last week for the first time. so I thought you might want to see another example. Okay, so I have two equations, both are in y equals mx plus b, or slope-intercept form, and notice that they are both equal to y, and because they're both equal to y, then I can equal them to each other. Okay, so I'm going to take this piece of this equation, which is equal to y, and make it equal to the other equation's part that's equal to y. This is called equal values method. Okay, and now you solve it like an equation we've been working on all year, so I'm going to start over here as I usually do. Plus 3x okay. Alright, so I got x equals -5. And then I'm going to plug it back in to one of the two equations. So I'm going to plug it back into the first one. Again, it doesn't matter which one you plug it back into. You'll get the same answer either way, but I'm just going to plug it back into the first one. Y equals -3 times -5 minus 21. Y equals 15 minus 21. Y equals -6. There are some of you, my visual people out there, who are probably going to like this, and there are some people, my formula people out there, who are going to like this. But what I want you to notice is that they're doing the same thing. If I had graphed these two lines, which I don't want to do because that one's down 21 and that one's up 14 for sure, the two lines would have a point of intersection, or they would cross at -5, -6. Also, this is a solution to the system, which means that if I plug -5 in for these x's and -6 in for these y's, both of these equations will be true. Okay, last one I want to do is number 17, and number 17 is it's an older concept we've been working on for a couple of weeks, but this particular one I find to be pretty interesting because you might try to do too much on this problem. So I just wanted to talk about it because it's easier than it looks. So the directions were to write the slope-intercept form of the equation of each line, which means rearrange this to look like y equals mx plus b. Exactly the same sort of thing I did up here. It's just that notice it's kind of all messed up. Okay, what we know is that the y needs to go in front. So the first thing I'm going to do is add y to both sides so that I can get it onto the left side of the equals. That will cancel, and I have y equals 5 plus 5x. Okay, and then because this is addition, I want to show you guys that you can actually just switch those around. Y equals 5x plus 5. And now I have y equals mx plus b form, and that problem is done. So sometimes these are a little bit easier than they look. Don't overthink them. I was afraid that some of you guys might try to move like these things over here away from the y, and then you'd have it backwards, but this one is actually, it looks kind of strange, but it's not too bad. Hope you guys are having a great week, and I hope this helps. Talk to you soon.